B is 4 to 5, and C is 7 minus 2, 4. Okay, so solution. Well, we also answered this thing using cross product, because you may remember that this cross product has such a property that, so let's say we have two vectors v and w, all right? Then we may consider this parallelogram defined by these v and w, okay? And this area, as you may know, is equal to the length of the cross product. So this is generally true, all right? So the reason, what is the reason? The reason is the following. Let me remind you. So because this v cross w is equal to length v, length w times sine theta, where theta is the angle between v and w, all right? And now you see the reason that this area equals this one by, so if you consider this height, so what is the height? This height is equal to length of w times sine of theta. So this is the height. That's why we have such a thing. Okay, so the question is, in here, so we have this triangle A, B, C will be equal to, so this area, well, this is a triangle, not a parallelogram, but, well, obviously that it will be half of the area of this parallelogram determined by these vectors AB and AC. So it will be, so this area of this triangle will be 1/2 times AB cross AC. Now we need the coordinates. So let's write the coordinates of the components of this vector. So components of AB will be B minus A. So let's compute. 4 minus 3 is 1. 2 minus 0 is 2. And 5 minus minus 1 is 6. Okay, yeah, by the way, I mean the absolute, the length of this vector. Yeah, 1/2 times. Yeah, let's also write the components of AC. So it will be 7 minus 3, which is 4. Minus 2 minus 0, which is minus 2. 4 minus minus 1 is 5. And length of this thing. All right. Okay, so let's compute this vector. So 1, 2, 3. And so 1, 2, 6. 4 minus 2, 5. Well, let me not write it here. You can compute. Just I will write the result. So this cross product, if you compute, it will be something like 22, 19, minus 10. So I'm taking, yeah, this is the vector. So this is the vector. And its length to be divided by 1/2. So let's compute its length. So you know that the length of this vector will be 1/2 times 22 squared plus 19 squared plus minus 10 squared. All right, and the result will be something like 15.37. All right. So this is the area of this triangle. Triangle is in space, doesn't matter, but we have this nice formula for the area of parallelogram. So it is just cross product. So we don't need to compute sine or anything. So this is the this is one geometric application of cross product. Well, this cross product has some other applications that you can see, that you will see when you discuss lines and planes. So let's now take some examples regarding dot product. Okay, so example. Again, let me take something geometrical looking. So the unit cube in the first octant in space has opposite vertices. Origin O, so you know its coordinates are 0, 0, 0, and P 1, 1, 1. So question is, so find the angle, between the edge of the cube, which one?
1, 2, 3, 4.
So on the one on the x-axis.
Berran portakalları daha büyük.
And what? So and the diagonal.
Kardeş olmak böyle demek değil mi?
OP. Okay.
Ses yapıyorum.
All right, so let's draw a picture first. So first octant is, you know, the part of the space where x, y, z are all non-positive or 0. And then we have this unit cube. So unit cube means the edges, they are all equal to have length 1, right? 1, 1, 1. And then, so this cube is going to be like that. Yeah, this is our cube. All right, so origin is here. This is one vertex of the cube. And then it says that the problem, the opposite one, the opposite vertex of this one is P. All right. So what will be the coordinates of P? They will all be 1, 1, 1. Because we are told that this is unit cube. Unit cube means cube whose edges have all equal to length 1. Okay, then, well, we have this OP, this diagonal. And then, so the question is, the angle between the edge of the cube on the x-axis and the diagonal OP. So x-axis is here. All right. So this angle we are talking about is this one. So let me draw the picture here. So there is OP here. And there is what? This edge on the x-axis. So if I want to write it as a vector, I should take I, right? I is the vector in the x direction, as you know. Okay. All right, so I'm wondering this angle, theta. So how can I find this angle? So, well, I can find its cosine. So cosine of theta will be equal to, you know, by our formula, OP dot I over length OP times length of I. Yes, this is our well-known formula for dot product. Okay. So let's now compute dot product. So first, let me write the components of OP. Components of OP is, you know, 1, 1, 1, of course. P minus O, right? Dot product, I, let me write the components. So I is the vector with components 1, 0, 0, divided by, now let's write length of OP. So length of OP will be 1 squared plus 1 squared plus 1 squared times length of this one is 1. Okay, now what is the dot product here? So 1 times 1 plus 1 times 0 plus 1 times 0 over square root 3. So the cosine of this angle is 3 over, not 3, 1 over square root 3. So theta will be equal to cosine inverse of square root 3. All right, so this is the okay, I hope there is not anything wrong in here. Yeah, cosine theta is this product. Okay, so let me now take, regarding this dot product, we have also this something called, yeah, but there is not, so something called a projection. Maybe I can take an example on this one. So example, so let V equals, this is the vector with components 4, minus 5, 3, and W equals to 1, minus 2. Okay. Then I ask, find the projection of V onto W. So here we will use a formula. So let me remind you how this works. So this is the vector V. This is the vector W. So these may not be actual lengths, but to give a picture, I have this one. So you see that projection of V onto W will be this vector here. So projection of V onto W will be given like that. All right. Now this will be given as the following. So our formula will be the following. So you see, how can we write this thing? So to write this one, we would need its length, right, and its direction. So the length would be length of V times cosine of theta, obviously, right? And its absolute, its length actually, its absolute value. And then we would multiply by this one, by the unit vector in that direction. So it will be the following. So V dot W divided by length W squared times W. All right. So the reason is that this length will be, so this component here will be equal to V dot W over W. So this length, I'm talking about this length, will be, the reason is that it will be like that. Okay. All right. So let's now compute these numbers. So what is V dot W? So it is 4 times 2 plus minus 5 times 1 plus 3 times minus 2 divided by length of W squared. And you know that this means W multiplied by itself. So it will be 2 times 2 plus 1 times 1 plus minus 2 times minus 2 times W. All right. So let's now compute this thing. Yeah. So we are going to have 8 minus 5 minus 6. So this will be 8 minus 5, 3 minus 6 minus 3 over 8, 4 plus 4, 8 plus 1, 9 times W. So it will be minus 1 over 3 times W. So W will be, so if we distribute this thing inside, so W is this one, so it will be 2 over 3, 1 over 3 plus. All right. So you see that this projection vector will be 1/3 of W, minus 1/3 of W. So this, how could this be possible? So my picture was not completely correct. So this can happen only like the following. So my picture, this is general, but it was not exactly like that. So it is like the following. See, V was here, V was here. So W was here, V was here. And when we take its projection, so we get this vector here. So this will be V minus, so this will be projection of V onto W, all right. And this will be equal to minus 1/3 W. This means, so minus counts for, this means that it will be, so this projection vector will have opposite direction as W, and its length will be 1/3 of this one. So it will be, if this is 3 units, then this will be 1 unit, for example. Okay, so this is the projection vector. Okay, let's now consider the following. So this, let's look at the difference. So what can we say about this difference? So I will draw the picture in here. Let me draw it again here. So I have W, and I have this V, and we have seen that so projection of V onto W is here. V onto W. So if you like, let's call this vector, this projection vector V1. Yeah. All right. So let me ask then the following. So if this is V1, so V1 is here now. Okay. So what is this vector here? So this is V1. So what is this vector? If this is V1, so let me draw this time this vector, which is this vector. So this projection, by the way, the projection is happens with 90 degrees. So orthogonal projection, as we say. Okay, so you may note that this vector will be V minus V1. Right? Yeah, because V1 plus. So what should I include so that? So this vector V1 plus this vector obviously should give this one. So you see this projection, yeah, V1, we can separate V into two parts. So V1, this is a projection, plus the rest, V minus V1, obviously. So, however, both of these vectors have some meaning. So this V1 is parallel to W, as we may say, parallel to W. So it is a multiple of W, right? So parallel means multiple of each other. Now this remaining part, V minus V1, this is perpendicular to W from, as you see from this picture, perpendicular Okay, so you see, this projection allows us to write this vector v as the sum of two vectors which are parallel to w and perpendicular to w. So we write it as the sum of some vectors which have some geometrical meaning. So this would be useful, and this is in fact some basic idea that we use in practice, as you may see later. Yeah. All right. So if one asks you to write, so this writes, one may ask you to write V as a sum of a vector parallel to W and a sum of a parallel vector and perpendicular. Parallel plus perpendicular to some vector we like, to W. All right. So if one asks you such a question, then all you need is to find this projection. And for the projection, we have this formula that I put here, and you probably have seen this one in your lectures, how to get this formula. So, yeah, this is one application. Okay, now finally, as a final question, let me take again some geometrical question to illustrate you how useful this vector is, vector notation. So let me take the following. Okay, so I hope all right, so let's consider the following thing. So let's say that we have a triangle. In the triangle ABC, we have a triangle. Let M N be midpoints. Of these segments AB and AC, respectively. Meaning that M is the midpoint of AB, N is the midpoint of AC. So question is, so show that this MN is parallel to AC. So I will draw the picture here, solution. So this is something that we all know very well. So I have this triangle ABC, and then I have this midpoint here, M. So this length is same as this one. And I also have this length midpoint, C. Now we know by our elementary geometry, our knowledge of elementary geometry, that if I consider this side MN, right? So this will be parallel to MN will be parallel to BC. So let's now prove this one using vectors and see how vectors could be useful. Okay, so let's start. So Now, when we hear the word parallel and vector, what do we think? So parallel means in vector terms being multiple of each other. So you see, if we want to show this mn as a vector, if we consider it as a vector, and this one as a vector, they are being parallel means they are multiples of each other, right? So it will be enough for us to show that these are multiples of each other. So let's try to see this one. So we are considering this vector mn, and, well, what is mn? So mn is the midpoint. Well, however, you see, we can also write this midpoint as follows. So mn, this vector now, for example, will be equal to, in this picture, we can write it as ma plus an, right? So this vector is going to be the sum of these two vectors, ma and an. All right. Now, this vector ma, well, this m is the midpoint. So it is going to be half of the vector ba, right? So this is equal to 1 over 2ba. Well, similarly, this an, the vector an, will be half of the vector ac. So it will be 1 over 2 ac, right? Okay, so this will be equal to 1 over 2 times ba plus ac. All right, now what is ba plus ac? So in this picture, we see that it is ba plus ac. It will be equal to the vector bc. So this is equal to this vector bc. So the answer is 1 over 2 bc. So mn vector, this will be equal to 1 over 2 times this vector, meaning that, well, it will have the same direction and its length will be half of the length of bc. So in particular, it is a multiple of this one. So since mn is multiple of this one, so mn is parallel to bc. As we see, this vector notation, in this vector notation, we can see this fact very clearly, very easily. All right. So in your book, there are also a few other problems regarding such geometrical problems, and I would recommend you to work on them to see how useful this vector notation could be. All right. So I think that's enough. So I hope everyone followed here. And so thanks very much. That's all for today.
Hocam,
Evet.
bunların kaydı alınıyor mu acaba?
Efendim?
Derslerin kaydı alınıp paylaşılacak mı acaba? Onu soracaktım sadece.
Ders dediğim benim yaptıklarımın mı?
Hocam, recitation. Bir
Ben
önceki
bunların kayıtlarını aldım, evet.
paylaşacak mı?
Paylaşabiliriz, niye olmasın? Ben nasıl yapılacağını bilmiyorum ama bakarız, evet.
Teşekkür ederim hocam, çok sağ olun.
Peki, evet. Başka sorusu olan var mı?
Hocam,
Evet.
sınavlarda hani mailde baştan sona olacağı yazıyordu. İlk gelen
Evet.
maillerde. Öyle olacak değil mi? Değişen bir durum yok yani.
Mailde nasılsa o da öyledir, evet.
Peki hocam. Teşekkür ederim.
Evet, rica ederim. Başka sorumuz var mı? Tamam, o zaman kapatabiliyoruz. Kapatırız. Teşekkürler, iyi günler.